In this video, I'm going to talk about ionic compounds containing transition metals, both going from name to formula and also formula to name. So before we get into naming and writing formulas for ionic compounds containing transition metals, we need to first talk about the basics of it. So in my poorly drawn periodic table, we are going to look at where transition metals are located. Transition metals are located in the D block. So this is the 4 rows here. In the D block, that's where transition metals are located. This is groups 3 through 12 in here. There are also some elements in the other metal region here under the staircase that are going to follow this exact same method of naming and formula writing. Now, the thing to look for when we are naming compounds that contain transition metals, in the upper right-hand box of some of the transition metal element boxes in the periodic table, you are going to look for the ones that contain multiple charges. So for instance, at the top of the box for copper, you should see a +1 and a +2. That means that copper, it's possible to have 2 different charges depending on which compound that copper is a part of. So you can have copper with the +1, or you can have copper with the +2. It all depends on the compound. But obviously, if we were just given the name copper oxide, so we have copper bonded with oxygen, this is not a name that is telling us specifically which one of these copper atoms is actually in this compound, okay? The importance of this is that if we were left alone to guess which one of these coppers to use in writing the formula, let's say that we chose copper with the +1. Copper is Cu, oxide is oxygen. If we chose copper with the +1, and we know oxygen is a -2, when you crisscross those, that would be your formula for copper oxide with the +1 on the copper. But let's say that someone else thinks that this is copper with the +2. So copper with a +2 and oxygen with the -2, equal and opposite, cancel out, left with just CuO. These are very different compounds. So leaving the guessing up to the person who is reading the name to decide what charge is on that metal is dangerous, okay? Getting these mixed up could lead to very dangerous reactions. So what we do to specify in the name of a compound containing a transition metal is we use something called Roman numerals. We put Roman numerals after the metal to state the charge of that metal. So for instance, let's say we were trying to refer to copper with the +2 in this compound. The way that you would properly write that would be copper 2 oxide. So this is telling the reader, instead of having to guess, that this copper is the +2 form. So it's really important that we are able to state that, because if you look at a lot of these transition metals, they can have multiple charges, and leaving it up to someone to guess is dangerous. Now, there are some transition metals that don't have multiple charges. So for instance, silver, or Ag, is always a +1. It cannot form multiple charges, so therefore, when you are working with a compound that contains silver, you do not need to put Roman numerals because it's always a +1. The other one is zinc. That is always a +2. So again, you don't need to put Roman numerals after silver or zinc because there's only one possible charge, kind of like all of the metals that are located in group 1, 2, and 13. Well, aluminum we used. Those have specific charges, so we didn't need to state the charge. Same with silver and zinc. But with the transition metals, the ones you have to look in the upper, again, right-hand corner of the box. So the ones with multiple charges, those are the ones that you have to use Roman numerals for. Let's try naming and writing formulas for some of these. So let's start with going from the name to the formula. So whenever you see these Roman numerals, you know that you are working with a transition metal, and you have to get used to the fact that this Roman numeral is stating the charge of the metal before it. So in this case, this is telling us that chromium has a +3 charge, because if you look at chromium's box on the periodic table, chromium can have more than one charge. Same with iron, same with copper. So again, when these are given to you, you are being told the charge of the chromium. You are not going to be able to guess and guess correctly 100% of the time if you aren't told which one it is. So if we go from name to formula, you want to start by writing out the symbols for both parts of the compound. So chromium is Cr, oxide is O. Then you go through and you're going to put the charges above them, just like we did with basic ionic compounds. We were told the charge on chromium is a +3. There we go. And then oxygen, you know, because it's in group 16, always is going to do a -2 charge. And then just like regular ionic compounds, we're going to crisscross. So this 2 above the oxygen is going to come down as a subscript on the chromium, and this 3 above the chromium is going to come down as a subscript on the oxygen. And that's the formula for chromium 3 oxide. So let's do it again down here. We have iron. If you look at iron on the periodic table, you will see in the upper right-hand corner that it can have multiple charges. You are told which one of those multiple charges this iron has. It has a +2. So when we go to make the formula, we write out the symbols. Iron is Fe, bromine is Br, and we're going to put the charges above them. Iron, you've been told, is a +2. Bromine, you know it's in group 17, and all elements in group 17 are going to gain an extra electron for a -1 charge. And then you just simply crisscross. So the 1 above the bromine is going to come down by the iron, but we don't write that. And the 2 above the iron comes down on the bromine for FeBr2. This last one is a little tricky, okay? Copper, you know, can be a +1 or a +2. You've been told that it's a +2. So we're going to start by writing out the symbols. Copper is Cu, sulfide is S. Now let's write the charges above them. We were told copper is a +2. Sulfur is in group 16, which you know all of those elements are going to form a -2 charge. Now normally, again, with the crisscrossing, you would bring the numbers down as subscripts, but you can stop here and see that these are equal and opposite. A +2 and a -2 are going to cancel each other out to give you 0. That means that you don't need to put any subscripts on this. You can leave it as CuS. So you just have to be careful with that, because Cu2S2 is technically incorrect. This is the only correct answer for this name. Here are 3 practice problems. You can pause the video and give these a try, and then hit play when you're ready to see the answers. So this first one, lead 4 iodide, we're going to start by writing out the symbols for both parts. So lead we know is Pb, iodine is I. And now we're going to go through and put the charges on them. Lead, if you look on your periodic table, can have multiple charges. We were told which one this lead is. It's a +4. So we are going to put a +4 above the Pb. Iodine is in group 17, so you know that it's going to have a -1. Then we need to crisscross. So you leave the plus and minus behind and you just put the numbers down as subscripts on the opposite element. So the 4 above the lead is going to go down as a subscript on the iodine, and the 1 above the iodine would go down as a subscript on the lead, but we don't write the 1, so this is just going to be PbI4. For the second one here, if you look at cobalt on your periodic table, you'll see that it has multiple possible charges. You've been told that this cobalt is a +3. So to start, we're going to write the symbols. Cobalt is CO, nitrogen or nitride is N. Cobalt, you're told, is a +3. Nitride is in group 15. It's going to have a -3. Now we would normally crisscross, but we can stop a second and look at this. +3 and -3 are equal and opposite. Those are going to cancel each other out. So we are going to have the final formula CON. For this third one, iron is Fe, phosphide is P, iron, we are told, has a +2, and phosphide is in group 15 as well. It's going to have a -3. Now we're going to crisscross, so the 2 above the iron goes down as a subscript on the phosphorus, and the 3 above the phosphorus goes down as a subscript on the iron to give us a final formula of Fe3P2. Now let's go from formula to name. So this is a little more tricky, but I have 2 different ways that you can do this. The first one is to use your periodic table and guess and check. So here you see CO, you know that this is cobalt, and if you look on your periodic table, I'm going to bring mine out, cobalt can either be a +2 or a +3. So I'm looking right here. Can be a +2 or a +3. So we can do the guess and check method. So if cobalt is a +2, we know that fluorine is a -1. When you crisscross these, this 2 would come down on the fluorine, the 1 would go on the cobalt. This is not the same formula. So let's try the other possibility. We have cobalt with a +3, and that's with fluorine with a -1. If you were to crisscross these, the 3 would come down, and we wouldn't write the 1. We see that this is the same formula, so we know this cobalt would be a +3. As long as you can figure out the charge on the transition metal, the rest of the naming is fairly simple. So we're going to name it the exact same way that we were naming basic ionic compounds. We're going to write the name of the metal, so in this case, it's cobalt. And also, if you're having issues naming just basic ionic compounds, please go to my video on that specifically, because that's kind of the stepping stone into naming ionic compounds with transition metals. So we're going to do the name, element name of the metal, and then we're going to do the name of the nonmetal with the ending IDE. So this is going to become fluoride. And normally we would be done at this point, but because cobalt can have multiple charges, we have to tell the reader which one it is. We determined through guess and check that cobalt has a +3 charge. So we are going to put after the cobalt in Roman numerals a 3. This is telling the reader that the cobalt has a +3 charge, not a +2. The other way to do this is called reverse crisscross. So that's where you look at these subscripts that we have in the formula, and we basically do the crisscross backwards. So we're looking at the 4 and the 3. If we reverse crisscross, we can tell that the phosphorus is going to have a -3 charge, and the lead is going to have a +4. Okay? So again, when we crisscrossed, they would have given us these subscripts. So we're just reversing that, we're going the opposite direction. So this is telling us lead is going to have a +4 charge. The only other option is a +2. So we know that this is going to be a +4 because the subscript on the second element is a 4. And when we see that, reverse crisscross tells us this is going to be a +4. If we would have done that over here, we would have gotten the same exact answer. We see the 3 on the fluorine, we would bring it up as a +3 on the cobalt. Okay, so then when we write the name of this, we're going to put the name of the metal, so Pb is lead. We know that the lead has a +4 charge, so I'm going to put 4 in Roman numerals, telling the viewer, the reader, that lead is a +4, not a +2. And then I'm going to put the name of the nonmetal with the IDE ending, so this becomes phosphide. And that's how you name this compound. Now there are some instances where I can try to trick you, okay? Or chemists can, really. These are all compounds that chemists use. So the trick is, when you see that both of the subscripts are 1s, so we see that NiO has 1 atom of nickel, 1 atom of oxygen, you have to stop and you have to question. Because if we were to do this reverse crisscrossing, you would think that nickel has a +1 charge. If we look at the periodic table that I have pulled up here, nickel can either be a +2 or a +3. That +1 is not even an option for nickel. So then you have to look at the charge on the oxygen. Oxygen is in group 16. You know that elements in group 16 have a -2 charge. So if we are a 1-to-1, that means that nickel has to be equal and opposite to cancel out this -2 to get this to be neutral. So if oxygen is a -2 and nickel has to be equal and opposite, it has to be a +2. The other way you can do it is the guess and check method. So you saw in here that nickel can either be a +2 or a +3. If we want to guess that this is a +3, we would not get out NiO as our formula. If we try the +2, we would. So that's how you can tell that +2 is the correct charge to use. So to name this, we are going to write out the name of the metal. We are going to put the charge of that metal in Roman numerals. So this is a 2 charge. And then we're going to put the name of the nonmetal with the IDE ending. So it's oxide. So this is nickel 2 oxide. Again, telling the reader that nickel is a +2, not a +3. The last one that we're looking at is AgCl. This is an exception to all of these rules. Let me show you. So if you look at the periodic table that I had pulled up, okay, I'm trying to get that glare off of here. You see that silver, and this is also on your periodic table, can only form a +1 charge. There aren't multiple options. Zinc is the same way. So chromium can be a +2, +3, or +6. Nickel can be a +2 or +3. Zinc and silver are exceptions. Silver is always going to be a +1, and zinc is always going to be a +2. So because it only can have one possible charge, you do not need to put Roman numerals after it, even though it's a transition metal. So this one, would be named the exact same way that you would name a basic ionic compound. So Ag, you know, is silver. We don't put Roman numerals after it because silver is one of the exceptions. Okay, silver and zinc can only be one charge, so you don't have to tell the reader which one it is because there's only one option. Okay, it's kind of like why we didn't have to put Roman numerals when we did like NaCl. You could just name this sodium chloride because sodium, we know it's a +1. We don't have to tell the reader that it's a sodium 1. It's the same with silver and zinc. So this is going to be silver, and then we're going to put the name of the nonmetal with the IDE ending. So this is silver chloride, and that is the correct way to do it. You don't need a 1 here because silver can only be one possible charge. So why don't you try these 3 practice problems? Pause the video if you need to. So let's start with the first one. We have ZnCl2. Zn, you know, is zinc. Zinc is one of those exceptions that I just mentioned earlier. It can only be a +2 charge. There are no other options. So since its charge is always a +2, this is one where you don't need Roman numerals. So the way that we name it, we are going to write out the name of the metal. So it's zinc. We don't put Roman numerals after it because zinc is always a +2. There are no other options. Then we are going to put the name of the nonmetal with the IDE ending. So this is zinc chloride. For the second one, you can either reverse crisscross or do trial and error. Either way, we're going to write the name of the metal, which is chromium. We're going to leave space because chromium can have multiple charges, so we need to tell which one it is. And then we're going to put the name of the nonmetal with the IDE ending, so that is oxide. Now to figure out what goes in these parentheses, if we reverse crisscross, right, this 2 would come up above the oxygen. This 3 would come up above the chromium, giving us a +3 charge. Or you can look on the periodic table. Chromium can either be a +2, a +3, or a +6. You can go through, plug each one in, and determine which one of these would get you this formula. So for instance, if we did +2, oxygen's a -2. Oh, let me move this up or down here. There you go. These are equal and opposite, leaving us with CrO. If we try with the +3 and oxygen with the -2 and crisscross, this 2 comes down by the chromium, the 3 above the chromium goes on the oxygen. We see that this formula is the exact same as this, proving that the +3 that we tried is in fact the charge of chromium. And the last one is one that I tried to trick you on. You notice that both of these subscripts are 1. Now you have to question me when both of them are 1 because it's not always as simple as taking the subscript of 1 and reverse crisscrossing. So let's look at bromine. Bromine is in group 17, so you know it has a -1 charge. That means, since it's a 1-to-1 ratio, that copper has to be equal and opposite in charge. That means this copper has to be a +1. So when we write the name of the metal is copper. We put its charge in Roman numerals. So this is telling the reader that copper is a +1, in this case, not a +2. And then we put the name of the nonmetal with the IDE ending. So this would be copper 1 bromide. So remember that the point of the Roman numerals is to show which of the multiple charges that the transition metal could possibly form it actually is forming for a given compound. So it's really important that we do these Roman numerals, but only if there can be multiple charges, okay? I am only going to be pulling out a couple of different transition metals, so if you want to highlight these in or on your periodic table, chromium, manganese, iron, cobalt, nickel, copper, tin. It's in group 14, but it can form multiple charges, and also lead. The only other one that I might pull out from time to time is gold, but out of all of the transition metals, I really only pull from those, if that helps you at all. So that is how you name and write formulas for transition metals, or ionic compounds containing transition metals.